Hi again, people. I guess it's the Janmashtami today that is keeping people from joining us at the webinar, probably because as of now we have about 15 people, whereas normally we have about 40 by this time. I would imagine that there'll be more people joining us during the course of the webinar once we start off. That said, without further ado, let me just get this thing kick-started. Before we go into the selection of solar equipments, I'll just explore the online solar cost and BOM calculator as a sort of a prequel to what is to come in the webinar. Easy Solar has made this tool wherein you could estimate the cost as well as the bill of materials, which is basically all the components which are involved in setting up of a solar power plant by making some minor quick observations, calculations in the Google spreadsheet tool that we have. One of the questions by one of the attendees, Mr. Niraj Patel, was that since this is a Google spreadsheet, so multiple people can edit it at the same time, as a result of which there might be interference. Well, that is a limitation right now that we have with this tool. But with due course of time, we'll take this tool online, after which each one of you could make their editing by themselves without interference from anybody else. Meanwhile, I would only request you to please wait your turn till the time that the person preceding you completes his calculations, which should not take more than a minute or so. Just to give you all a preview of what this tool is, this is what the tool looks like. So anybody can change the capacity. Say, let me take the capacity as 100 kilowatt. You could choose which kind of system do you want: RCC, shed mounted, ground mounted, etc. Say I have got a shed mounted system. You would see that it takes some time to load. However, if I have taken the shed mounted system, the profile of mounting structures has changed to aluminum steel profile. So there is this background logic that we have already built into this Google spreadsheet, logic that probably you won't be able to change. Then there is also an option of whether you can provide a CFOM or not, based on which the taxes of 5% or 2% is applicable. I'll leave it to yes. Then you have got a few choice of modules. You have got choice of what size of modules do you want. You have got choice of inverters and sizes of inverters. This is by no means an exhaustive list. I assume that people would have access to a lot more inverter makes and module makes. There might be other kinds of system also, but this is the pricing for which these are the makes for which Easy Solar already has the pricing, and you can order with Easy Solar. To be fair, the pricing might be a little higher or lower than the pricing that has been given. This is only an indicative analysis. The exact pricing can only be found out once you give us the exact queries of the size and the delivery location of your project. At the end of the day, you can see over here that the total cost is calculated, and also the total cost is calculated in terms of rupees per watt peak, right? So you could also procure all of these equipments on SolarCart online. SolarCart is India's first marketplace for solar products which are involved in a solar power plant. As you can see on the screen, you have Solar Design, SolarCart, and Solar Connect. Let me just log into SolarCart. Here are all the modules, inverters, structures, peripherals, etc. that you can purchase on SolarCart. Now, with this covered, let me resume with the webinar. We have a couple of more people which have joined us now. The host for today are myself, Puneet Singh Jaggi. I'm the director at Easy Solar, and my colleague Shivya Singhal also joins me. She is the COO at Easy Solar. Both of us have got a wide experience in designing and execution of rooftop as well as utility scale power plants. Uh, to just give you a background of how this webinar is going to run, I'm going to be taking the presentation part of it while my colleague joins in answering all the questions at the end of the webinar. For raising any questions, you could type in the questions tab, and we could take it up later, or alternatively you could also click on the hands button in the on the corner that you see, the control panel that you see in the corner of your screen over here on the right side corner of your screen. Right. So by either of the two, I'll get to know that there is a question, but it'll be better if you type out a question, because that will save us time later on. Now, there are a couple of problems which are plaguing the procurement side of solar rooftop business. The first problem that we very often encounter is that during procurement, the only focus is cost. And speaking of cost, a quotation by John Glenn, who is a senator in the US and who was an astronaut earlier, he had said once that somebody had asked him that how did you feel sitting in the rocket, and his answer was that I was sitting in the rocket. The only thought that was coming to my mind is that every part of this rocket was supplied by the lowest bidder. Right? So the similar scenario is that of a solar power plant, wherein very often the procurement is based purely on the basis of how cheap can you get an equipment, and not necessarily how best suited is it for your requirements. Sometimes it also happens the other way around, wherein your procurement is more expensive because you're going by some ballpark assumptions, or probably because the engineering is not sound, whereas probably the procurement can be done at a lower cost. My point is that whether you are underspending or overspending, the plant engineering has to be correct as far as design is concerned, and that is the sum of some aspects of that design or selection of the right equipment we are going to cover in the webinar today. The second problem that we see during procurement is that a lot of attention is given to modules and modules alone, right? So this is what should happen, that all the equipment parts, whether that be modules, inverters, earthing, lighting arresters, lugs, junction boxes, cables, all of them should get equal importance, because any of them fails, the entire system fails. But what we have very seen, what happens is this, that module grabs all the attention and all the other BOQ is ignored. The typical dialogue that an EPC contractor or the business development division of an EPC contractor has with its clients is about modules, at best about inverters, about the warranty conditions about these two, and the rest of the bill of materials is tucked away neatly, which shouldn't be the case. So based on these two problems, what our intention was is to give the audience an idea of how to select all the individual equipment which is involved in the solar power plant. Not only module, but module, inverter, lighting arrestor, cables, everything. Moving on. So as far as modules is concerned, there are a couple of very straightforward factors while selecting the module. The first common misconception that we have seen among system integrators is that people usually think that more is the number of cells or larger the module size, and it is going to be costlier and better. Now, for anybody who is a little who has got a little bit of engineering background in solar, they will be able to understand that that is not the case. But for those who don't know about it, the size of the panel is of little consequence. The efficiency of the panel is what matters. So, if somebody is selling you, for example, a 250-watt peak panel of 72 cells, then probably he's telling you last year's stock, because those kinds of inefficient panels are no longer made. Typically, a 250-watt peak panel would be made into 60 cells, right? So typically, you would have a 250-watt peak panel. The dimension would be 1.6 meters into 1 meter. If you have got a very inefficient panel, then probably it will be 72 cells at 250 watt peak, which should have a dimension of say 1.9 into 1 meter. The point that I'm trying to make is that while evaluating different panels, you need to check out the efficiency and not necessarily the number of cells, and not necessarily the dimension of module. The second thing that you should always check, that the tolerance level provided by the supplier is only positive. It's not too uncommon to see that the module supplier in his specification sheet as well as in the order he requests for 250 watt peak plus minus 5%. What needs to be done and what you need to ensure while you raise a purchase order to the supplier is that it cannot be negative. It should only be positive. A 250 watt peak panel can be 250, 251 up to 254. What it cannot be is 249 or 248 up to 246. If it goes beyond that, it will be categorized as a 245 or a 255 watt peak panel. The third thing is temperature degradation. Now, more or less, crystalline solar panels and thin film solar panels independently have got their own separate temperature degradation. And within crystalline panels, you would find that the degradation is more or less same. But basically, what this degradation refers to is that all of these panels, the rated power that you get, whether that be 250 or 300 watts, etc., is going to be at a particular temperature, which is 25 degrees Celsius, when there is enough sunlight available. But what happens is that when you keep on growing the temperature above 25 degrees Celsius, which is very common in Indian conditions, the panel output starts to decrease. This is slightly to the contrary of what people typically assume. People assume that more the heat, better the output. That is exactly the opposite of what actually happens. A solar panel is made of silicon, the same material which goes into your chips in your computer. And like your computer has a fan to keep the solar chips cool, similarly, a solar module works best under cold conditions. So lower the temperature degradation, the better it is. Then there is the concept of bypass diodes and bus bars. This is typically important when you have got shadows which are being casted on the module. Say you have got a tree which is close by, or a pipeline on a rooftop, or a water tanker on the rooftop, something of that sort, which can possibly have a shadow at some point of time or the other. Or if the location is prone to get a lot of cloudy weather, then there'll be some shadow on one part of the module, and the other part of the module might be without shadow. In that case, what happens is that more the number of bypass diodes and more the number of bus bars you have, the module output is going to be higher, even if the module is partially covered by shadow. Lastly, coming to PID losses, PID refers to potential induced degradation. Not getting into the technical aspects of it, what PID essentially means that under some adverse weather conditions, the module starts degrading at an exponentially higher rate, right? When you have got very high humidity and very high temperature, which is not too uncommon in Indian conditions, the panel output can degrade by as high as 40%. So ideally, if you can get anti-PID panels from panel suppliers, that is best. Otherwise, there are other modes of protecting yourself against PID losses, one of which is negative grounding protection in the inverters. Moving on, the makes that we have available at SolarCart and ezysolare, which can be sold online, are Vari, Vikram, Navitas, Alpex, PV PowerTech, and we'll soon be adding a couple of more. So, in case you would want to order any of them, we'd be happy to help. Coming next to the inverter. Now, there are multiple factors which should affect the choice of inverter that you have in a solar power plant. The first factor is that of MPPT voltage range. What does this voltage range basically mean? Let me just graphically tell you what this basically means. What a voltage range basically means is that, say, for example, your voltage range was, for the sake of some easy understanding, say it was 24 volts, right? Now, if it was 24 volts, then possibly, and if each of your panel had a 3 voltage output, you can put a maximum of 8 panels in series, right? 24 divided by 4, divided by 8, it is 3, right? So 3 volt panels, so you'll have more number of strings. Whereas if instead of 24 volts, you had 36 volts as your MPPT voltage range, then you would have been able to have 12 modules in series, right? So as the voltage range keeps on increasing, the number of strings of modules keeps on decreasing. And as the number of strings keeps on decreasing, rest of the equipments that you have to procure per string, whether that be MC4 connectors, length of cables, structures, etc., all of that keeps on decreasing along with that. So higher the MPPT voltage range, better is going to be your cost and lower is going to be your BOQ. Moving on, the next thing is going to be maximum DC voltage range. Now, what does a maximum DC voltage range basically mean is that the maximum current or the maximum voltage that it can take from a module string. What happens is this is a typical graph in a day of solar generation, right? In early morning hours, you don't have generation. In late evening hours, you have generation. You don't have generation, and in the noon, you have the maximum generation. But if you have got a lower range, then even though your plant is generating power, but that power is going to get clipped. Whereas in case you are having a normal voltage range, it won't. And in case you have a higher voltage range, then you can put much more panels in series, right? So this is the examples that I'm giving are all empirical. They are not exact. They are just meant for indicative purposes. But essentially, what a larger voltage range would mean that you would be able to have larger panels in series. Then the third thing is the number of MPPTs. MPPT, technically speaking, is maximum power point tracking device. But essentially, what it means is that for every MPPT, you should you can have a number of strings, right? So say for example, if one inverter has one MPPT, then it can take and it has got three inputs. Then all of these three inputs are being tracked by the same MPPT. The problem with that tracking is that even if one string is under shadow or even if one string is performing lesser, then the impact of that is on all the other two strings also, which are connected to the same inverter, which is having only one MPPT. Whereas in the same case, if we had three MPPTs in the inverter for all the three individual strings, in that case, the impact of a lower string voltage and current won't have impacted the other two. So the plant performance would have been better. So higher number of MPPTs, better the inverter. The next is the number of inputs. This is fairly straightforward. Larger the number of inputs, larger the number of module strings that you can connect to the inverter. And as a result, lesser the number of inverters that you would need to have. The next thing is input DC protection. Some inverters already have it, some inverters don't. The key thing over here is that there's a possibility to have faults on the DC side as well as on the AC side. And there are protections that you should have in the inverter, ideally on the DC side. In case you do not have these protections, you need to install it separately as well, right? So in case, for example, inverters like SMA typically can come with an inbuilt surge protecting device, which protects the DC part of current from any faults that might enter into the inverter. So, if in case there's an inbuilt SPD or an inbuilt DC protection, you don't have to install a separate part, so that cost is saved. The next part is communication. The inverters typically have both models. One is with communication and the other is without communication. If I take the example of SMA, then SMA comes with and without web connect. Although it is obviously recommended by all means to have a remote monitoring functionality with your inverter. If you're investing money, 5 lakhs, 50 lakhs, crore, 2 crore rupees, and even more in a rooftop solar power plant, by all means, you should be able to monitor it remotely as well. But there's a cost to this communication, which you need to factor in. And in case you do not have the specs and you are being sold an inverter, it is best to check whether communication is included or not. The next thing is IP rating. IP rating basically refers to how robust is the inverter to outside environment, right? So IP65 and IP67 are amongst the best ratings in the inverters, which means that the inverters are protected from dust as well as from the spray of water as well, right? So an IP rating would determine whether you have to build a separate enclosure for the inverter or whether it is okay to just wall mount the inverter in outside surroundings. Whether it is required to have even a canopy or you could do away with a canopy as well. So some amount of civil cost is going to be saved in case your IP rating of the inverter is good. The next thing is display. This is pretty straightforward. More the number of parameters that you can track on the display on the inverter itself, better it is for the sake of convenience. The makes that we have available as of now on SolarCard that can be ordered are SMA, Zever Solar, Fronius, Kako, Schneider, and Flynn. There are others also that we are adding. So in case you do not see the make that you want over here, be free to reach out to us, and I'm sure we'll be able to arrange a quotation for you. Moving on, cables. Now, when it comes to rooftop cables, there are two kinds of cables. There is a copper cable and there is an aluminum cable for rooftop solar systems. As far as copper cable is concerned, it is mostly used for DC side and sometimes used for AC side. When I say DC side, I mean from modules to inverters, the connections are made from copper cables. And from inverters, there are inverts to junction box or to your load, it is made on AC cables. I'll first describe the DC cable. Whether that be DC or whether that be AC, there'll be certain losses that the cable has. The larger the size of the cable, the larger its cross section, the lower are going to be the losses per meter. So a 4 square mm cable is going to have more losses than a 6 square mm cable, and a 2.5 square mm cable is going to have further more losses over a 4 square mm cable. As a ballpark, in a 100 kilowatt power plant, probably anywhere in the range of about 1.5 to 2 kilometers of cables is used. And again, as a rule of thumb, if any length of cable is more than 80 meters, you should probably go in for 6 square mm cable. If the length of cable is lower than 80 meters, then you should go in for a 4 square mm cable. Needless to say, the 6 square mm cable comes at a higher cost in comparison to a 4 square mm cable. This was about the DC side. Remember that in DC side, it is mandatory for you to use only copper cables. Whereas when we come to AC side, it is possible to switch between copper and aluminium. Now, an aluminium cable would typically start from 10 square mm. It won't be less than 10 square millimeter. The sizes which are available in, say, aluminum or copper cable for that matter are 10, 16, 25, 35, 50, 70, 120, etc. A copper cable is going to be cheaper than an aluminium cable. Sorry, my mistake. An aluminium cable is going to be cheaper than a copper cable. But the difference over here is that an aluminium cable, you would require a larger size in comparison to a copper cable. The two things that we typically match are the per meter loss of aluminium versus copper and also the ampacity or conductivity of aluminium versus copper. In both the cases, considering that copper fares better than aluminium, so that is why typically for one size of copper cable, the next size of aluminium cable might be required. So if you were planning to put a 10 square mm copper, if you need to replace it by aluminium, you'll probably have to go for a 16 or a 25 square mm aluminium. If you're planning to put in 16 square mm aluminium, 16 square mm copper, probably you should go for a 25 square mm or a 35 square mm aluminium and so on. The catch over here is also that even on a higher size, the aluminium cable might still be cheaper in comparison to the copper cable. However, one thing that you need to take into consideration while purchasing aluminium cable for AC side is that certain inverters have these preconditions that to use only and only copper cables on the AC side. As an example, SMA would not be able to honor its warranties in case aluminium cables are used on the AC side. Right? So it is always recommended to use copper cables on the AC side when you have got certain inverter makes such as SMA. For others, the inverter makes it slightly more flexible, so that's why you could probably play around whether you want to use copper or aluminum based on what is the price that you're getting. Lastly, another parameter is sheathing and temperature. Sheathing basically refers to the outer coating of the cable. Typically, the sheathing should be UV protected, which means that if you are going to use the system, if you're going to lay the cable in an open environment, it is obvious that it will be exposed to ultraviolet rays in the sunlight. And if you want to protect that, then the cable should have UV sheathing. Otherwise, you should definitely use conduits to put in all the cables, and you should never get cables exposed. Similarly, there are cable suppliers who have different types of cables, type 1, type 2, type 3, which depends on the temperature suitability of the cable. So type 3 works at the lowest temperatures, type 2 might work at slightly higher temperatures, and type 1 will work at further higher temperatures. The cables that we have available at SolarCart include Polycap, Seachem, Hevels, KEI, Apar, and we are in talks with the others as well. So be free to order one of these cables makes with us as well. Next important thing is the structures. Now, the structure as such, we do not have many makes available in India because it is not a standardized commodity when it comes to makes, or it is essentially a highly commoditized item. But the structure, essentially the modus operandi around structures is that you design a structure, you try to find a supplier of the structure locally close by so that the freight cost is minimized. But the design of the structure determines the tonnage that you need to order or the weight that you need to order, which determines the pricing. The design of the structure, in turn, is first of all impacted by the location of the site, right? If it is in southern India, then the tilt will be slightly lower. If it is in northern India, then the tilt will be slightly higher, which will make changes to the design. The next thing that will be determined upon is what kind of roof are you working on? Is it a shed? Is it an RCC roof? Is it a ground mounted system? Or is it a superstructure that you're building? Different structure rooftop types will have different kinds of structures. A roof RCC rooftop and a ground mounted would have more or less similar weight of structures. A superstructure would have almost double. Say if you have got 60 kgs per kilowatt for a rooftop or a ground mounted, probably you will have to use 100 to 120 kgs per kilowatt for a superstructure. Similarly, but a shed mounted structure would be considerably lesser in terms of weightage because you don't need to have the columns and the purlins and a lot of other components in these structures. So the shed mounted might be okay with a 35 to 40 kg weight. However, the key over here is that sometimes the material needs to be different. Typically, cold rolled iron as well as hot dipped galvanized iron is used for structure making. But if you have a shed mounted structure, you might have to go in for an aluminum profile of structure, which is much lighter, which can be the load of which can be easily borne by the roof. The next thing is thickness of the roof. Thickness of the roof essentially determines whether you would have to have a ballast foundation or whether you can dig into the roof a little and have a J-bolt inside the roof or a Hilt inside the roof. This is particularly even more important when you have a shed-based roof and you need to make penetrations in the roof type. I cannot get into all the details because that might not be in the scope of this webinar, but it is suffice to say that single most important thing is the location and second most important thing is the type of roof when determining the structure. The height of the structures and the wind zones would also determine what kind of strength you would need the sections to have and accordingly what weight the structure would be. The next component is earthing strips and rods, often the least understood part of a solar system. Now, while designing any earthing strip or while designing any earthing system, there are a couple of ground rules that you should have in place. Number one, the AC side and the DC side should have different electrical earthings. Right? What I mean is that the modules and structures on the DC side needs to be earthed separately, and the inverters, the junction boxes, etc., on the AC side need to be earthed separately. The neutral electrical earthing needs to be a third separate altogether earthing. And lastly, the lightning arrestor should have its own separate earthing too. Right? Also, ideally speaking, you should have redundancy. According to the standards of design, you should have redundancy, which means that wherever you are having one earthing pit for one kind of earthing, you should also have a redundant second pit. That makes it two DC side pits, two AC side pits, and two pits for lightning arresters. This is often not followed in Indian circumstances, but this is what the standards say. The third thing is also about how do you determine that what is the size of the earthing strip that you need to put. There are two kinds of earthing strips which are typically used. There's a 25 into 3 earthing strip, which is basically referring to the cross section area, and the other earthing strip is 50 into 6 Now, in rooftops, as a rule of thumb, which is broadly applicable, you can use 25 into 3 and be okay with that. For utility scale power plants at many locations, you will have to use a 50 into 6 The reason for that is that in rooftops, the run of the cable, run of the earthing strip, or the length of the earthing strip is not very high, and as a result, the rule of the total resistance in the earthing strip being less than 1 ohm can be easily followed even with the 25 into 3 earthing strip. This was about the earthing strip. The next thing is about the earthing pit. What happens in the earthing pit is that there are two kinds of rods that you can use. There's a copper rod and an iron rod. Now, the conductivity of copper is better than iron, and as a result, if you are using 3 meters of iron rod, a 2-meter copper rod would also suffice. Or if you are using a 50 radius iron rod, even a 40 or a 30 copper rod might suffice. Right? So, obviously, copper and iron has different costs, and as a result, you'll have to make a commercial call on it while installing. Currently, we have got SGI and GMB as two of the suppliers for earthing rods and equipment. The next thing is the lightning arrestor. Lightning arrestor is again one of the most neglected parts of a solar rooftop system. There are two kinds of lightning arresters which are available in the market. One is a conventional lightning arrestor and the other is an ESC type of lightning arrestor. The ESC is basically early streamer type. The key difference between the two is that a conventional lightning arrestor will arrest the lightning only if it falls on top of it, right? Whereas an ESC type lightning arrestor attracts the lightning to itself and makes sure that the system is protected against lightning falling on the plant, right? Obviously, the cost of an ESC type lightning arrestor is probably 10 times higher than that of a conventional lightning arrestor for the same reason. But where you might require 5 conventional lightning arresters, probably a single ESC type lightning arrestor might suffice. This is often determined by the client requirements as well. Now, whether that be a conventional lightning arrestor or an ESC type lightning arrestor, both have got a radius coverage which is determined also in part by the height of the arrestor. For a conventional lightning arrestor, the rule is pretty straightforward. The total height of the lightning arrestor would be the same as the radius that it can cover. So if you have a 10-meter high lightning arrestor, it would be able to cover 10 meters of radius around that installation. An ESC type lightning arrestor, however, comes in different shapes and sizes. It can go up to 107 or 109 meters of protection as far as radius is concerned. And it obviously starts with a much smaller radius, right? So, whether you're going for conventional or an ESC type, you should ensure that the entire plant is completely covered as far as lightning arrestor protection is concerned. The make that we have available as of now is SGI when it comes to lightning arrestors. Coming to junction box. Now, we have already explained about the DC protection box that sometimes comes in front of the inverter. So, the junction box that I am referring to right now is basically the junction box which is put after the inverters. You would typically have probably three, four, five different inverters in a solar rooftop system, depending on how large your system is. Say if you have a 100 kilowatt system and you have five inverters of 20 kilowatt each, then all of these five inverters might come to a single junction box where all of this current from five different inverters gets added up and then sent across to the load, which is basically sent across to the building where this needs to be used. So that is one function of the junction box, that it combines the currents. The other function of the junction box is also to offer AC side protection, which is basically that in case there is any fault or surge in the AC side, the system is protected against any of that. So, which means that on the input side of the junction box, you would need to have NCBs, and on the output side of the junction box, you need to have NCCB. The cost of the junction box is impacted by the number of inputs, the number of outputs, the rating of the inputs and the outputs, a bus bar at which all the inputs and outputs is connected, which determines the current rating of the junction box, and also by the protection that you want in the junction box. In some cases, you can fit the energy meter also inside the junction box, so the cost might also be impacted by that. Currently, we have got Hensel, 1XS, and a couple of other makes which are available with us. So, this is all the equipments that we wanted to discuss as of today. We'll be taking the questions shortly, but that said, in case you would want to order any of these equipments online, you could just give my colleague or myself a call and we'll get back to you with the most cost competitive quotation. You could also explore SolarCart online, which is available at solarcart.ezysolare.com. Over here, you would find most of the equipments listed already. A couple of other services that we are already providing right now are energy assessment services, layout for any kind of solar power plant, and detailed engineering for rooftop solar power plants. So you could explore this also in the solar design section on the website. Coming to questions, let's see if we have got any questions now, which my colleague and myself can take. So one of the questions is how many bypass diodes must there be in a module? Now, typically, it is very common to have two bypass diodes in a module. However, sometimes there are more than two, three bypass diodes also available in some modules, which is a better scenario. The next question, considering temperature coefficient, if temperature is less than 25 degrees, then does the power generation increase? The answer is yes. In case you are going for a lower temperature area where the temperature of surroundings and of the module is less than 25 degrees Celsius, then yes, the performance of the module actually increases. In fact, Japanese researchers have come to the conclusion the best place of setting up a solar power plant is in Himalayas because in Himalayas the temperature is extremely cold and the radiation is extremely high, and because of which you can get the best possible output. The next question is what is MPPT? I'll ask my colleague to answer this question for me. Shiva?
Basically, MPPT is as Puneet sir said, that multi power point tracking system. Basically, it covers the what is the range of MPPT. Basically, there is a voltage range with every string inverter. on which we can decide the string sizing. If you have the let's say MPPT range of 350 to 800 volt, that means minimum string should have 350 volt, or maximum it should have 800 volts of uh, string voltage. So wider the range is the what wider the range is recommended for the MPPT range. Besides the MPPT range, we can talk about the MPPT numbers. If we have single MPPT, then we can use only one string size in that inverter. But if we have number of MPPTs, let's say two or three, we can have the different sizes of string in that inverter. So we can have the flexibility of designing with the multiple MPPTs.
To just further elaborate on Shivya's answer, an MPPT is a maximum power point tracking device. It's a device inside an inverter which tries to extract the maximum possible power out of every string. But in case there are multiple strings which are there to attach to a same MPPT, then what happens is that the power output that it is able to extract becomes slightly limited on account of the lowest string which is connected to it. Whereas more the number of MPPTs, the better it is. I think we have covered most of it already in the discussion. Uh, what is the hourly percentage of a solar generation in a day, referring to the bell curve? Basically, I understand the question is that from 8 a.m. to 9 a.m., what is the power output? 9 to 10, what is the power output? And so on. It's a slightly difficult question to answer because it completely depends on the location of the power plant. If you order the solar energy assessment report, possibly we could attach an annexure along with that, which tells you about the distribution of power on any given day. This would also differ according to different seasons of the year. What ratio should be considered in aluminum cable using in place of copper cable? As a ballpark, again, probably Shivya could explain this.
As a ballpark, you can use the next higher size of aluminum cable in place of aluminum cable. For example, if you are ordering for, let's say, 3.5 core copper cable of 16 square mm, it would have ampacity of, in air it would have ampacity of approximately 70 amps. And if you want to replace it with aluminum cable, you can have the 25 square mm 3.5 core aluminum cable with the ampacity of approximately 90 or 95 amps. So you can always use, as a ballpark figure, you can always use the next higher size of aluminum cable in place of the copper cable.
The next question is how to calculate the correct tilt. Again, there is a broad rule of thumb around it that the tilt of any particular location should be same as the latitude. But ideally, you should use the sophisticated softwares that we have at our disposal. For example, the likes of PVSys, which is the most commonly used industrial software, to find out the tilt according to a particular location. You could also get the same at Solar Energy Assessment Report, which probably you can explore on solar design. The other thing is also that tilt is sometimes also dependent on the total area that you have, because if you have a 30-degree tilt, then there's going to be some shadow behind it. In case you have a 25-degree tilt, the shadow is going to be smaller. In case you have a 10-degree tilt, it's going to be further smaller. So when you have got less area available and you want to fit in larger capacity, you keep on decreasing the tilt so that you could fit in one row behind the other without casting any shadow. Moving on, can we use earthing cables instead of earthing strips?
Yes, we can use the earthing cable instead of earthing strips, but it can be used only for the depends upon the size of the your project and the design of the project. But yes, we can use the earthing cable as well. Generally, for the DC side, we are generally we all of us using the earthing cable, not the earthing strips.
Moving on, how to calculate the number of lightning arresters in a project?
Basically, you should know the what is the area covered for your project. If you are having the area, let's say 100 meters of 100 meters in on one roof, you are putting your solar plant. So your LA should be more than 100, so that its covering range should be more than 100 meters. So you can go with the type to E. If you are going with the EAC type LA, you can go with type 2 LA with 107 meters or 105 meters range of radius with LA.
Moving on, what are the considerations for SMA battery inverters? See, so the battery inverters have a lot of different other considerations to make in comparison to a non-grid inverter. Uh, Although the scope of the webinar might not be able to cover the entire thing, but just to give you a quick idea, you need to understand what is the voltage output of the inverter. You also need to understand what is the protection that the inverter already has in itself to protect the battery system from any kind of faults or any kind of surges. Right. So these are just some of the factors. Probably in a separate, dedicated only to batteries webinar, we'll be covering the right parameters that you need to focus on while designing a off-grid system as well. Are the solar panels connected in series or in parallel? Probably Shivya, if you could answer this.
Once in one string, we will use the solar panels in a series, and different strings are connected in parallel. So we have both. Uh, we are using series as well as in parallel. In one series, we should have the series of connection of panels, and strings are connected parallel with the inverter.
I think we are done with the questions for today. There are some other questions which I'm afraid I'm not able to understand properly because of which we are not taking. That said, thanks a lot for being a lovely audience. If there's any further question that you might individually have, you could write to Shivya or myself. My email ID is displayed on the screen, puneetjagi@easysolar.com. Shivya's email ID is shivyasinghal@easysolar.com, shivyasinghal@easysolar.com. A recording of this webinar is going to be available to all the attendees and also all of those who had registered but could not attend by the next Tuesday. Thanks a lot, everyone. Thank you for being a fantastic audience.